Scattering parameters, Magicity and rat race series on microwave engineering, lecture number 2.15. The most appropriate, the most suitable technique for the modeling of microwave circuits or microwave junctions is the one which uses S parameters. There is a certain procedure, a specific method for use in modeling microwave circuits with S parameters. In the present session, the focus is on modeling two microwave circuits, two microwave junctions, namely magic T and rat race with S parameters. While deriving S matrices for these two circuits, here it is also intended to illustrate and explain various steps that are there that are always used in characterizing the devices with S parameters. Now let us move to the core session where first we take up S matrix derivation for magic T and then we go to rat race circuit to derive its S matrix. Before going to the actual process of modeling, actual process of deriving S matrix for magic T, a few points as introductory remarks. To model magic T with a S matrix, consider an ideal one. The S matrix of magic T with respect to the port numbering given is S is equal to 1 by root 2, 0, 0, 1, 1, 0, 0, minus 1, 1, 1 minus 1, 0, 0, 1, 1, 0, 0. This matrix is with respect to the port numbering given in the symbol is shown by the side of the matrix. Here, collinear arm ports, they are given numbers 1 and 2. H-arm port is given number 4. E-arm port is given number 3. It is required to be mentioned here the fact that matrix is specific to numbering. When numbering is different, matrix also different, a changed one. Now let us move to the procedure proper. The magic T is a 4-port junction. It is a 4-port device. Hence, its S matrix must be a 4 by 4 square matrix. Let it be S equal to S11, S12, S13, S14, S21, S22, S23, S24. S31, S32, S33, S34, S41, S42, S43, S44. Now somehow we have to find values of the elements that are there in this matrix. Total 16 elements are there. So 16 unknowns are there. Somehow we have to fix values to these 16 unknowns. In magic T, all the ports 1, 2, 3, 4 are perfectly matched to the junction. And hence, S11 equal to S22 equal to S33 equal to S44 equal to 0. Also, the ports 1 and 2 are perfectly isolated from each other, as are the ports 3 and 4. 1 and 2 are collinear ports, whereas 3, 4 are side-arm ports. They are isolated. Hence, the parameters S12 is equal to S21 equal to S34 equal to S43 equal to 0. Incorporating these two aspects, the matrix becomes 0, 0, S13, S14, 0, 0, S23, S24, S31, S32, 0, 0, S41, S42, 0, 0. Notice in the matrix with which we have started, the number of unknowns are 16. Now, number of unknowns, the second step, after the second step, they become 4 plus 4, 8. Number of unknowns are fewer now than the number of unknowns when we started the process. As the junction is ideal, it must be reciprocal and hence the matrix must be symmetrical. It implies Sij is equal to Sji for I not equal to j. Also in magic T, the E arm port 3 is electrically antisymmetrical with respect to ports 1 and 2 and hence S11 equal to S22 and S23 equal to minus S13. Similarly, H arm port 4 is electrically symmetrical. Port 3 is antisymmetrical, whereas port 4 is symmetrical with respect to ports 1 and 2. Hence, S11 equal to S22 and S24 equal to S14. Incorporating all these aspects, now the matrix becomes 0, 0, S13, S14. 0, 0, minus S13, S14. S13 minus S13, 0, 0. S14, S14, 0, 0. Notice the unknowns right now in this matrix. Their number is 2. One is S13, another is S14. Now from 16 number of unknowns to we have come to a point where the number of unknowns are just 2. Now it is required to find the values of S13 and S14. As the junction is an ideal one, it must be lossless also and hence S matrix is unitary. 1. Obeying unity and 0 properties. To find S13, apply unity property to column 3, C3 of the matrix. To obtain S13 magnitude square plus S13 magnitude square is equal to 1. It gives S13 magnitude as 1 by root 2. Now adjusting the reference plane at either port 1 or 3, let us say 3, the phase of S13 can be made 0 and hence parameter S13 becomes equal to 1 by root 2. Now to find S14, apply unity property to column 4 C4 of the matrix to obtain S14 magnitude square plus S14 magnitude square is equal to 1. It gives S14 magnitude as 1 by root 2. Now by adjusting the reference plane at either port 1 or 4, let us say 4, the phase of S14 can be made 0. Hence, parameter S14 is 1 by root 2. Substituting the found values of S13 and S14 in the matrix, the S matrix of the magic tape becomes 0, 0, 1 by root 2, 1 by root 2, 0, 0, minus 1 by root 2, 1 by root 2. 1 by root 2 minus 1 by root 2, 0, 0, 1 by root 2, 1 by root 2, 0, 0. Of course, 1 by root 2 can be brought out. Notice this is the matrix that was given, that was shown in the beginning when we started the derivation process of S matrix for magic T. The signs of the elements in the third row and third column of this matrix may be reversed depending upon the polarity assumed for port 3. Next circuit or device we consider in the present session for modeling with S parameters is rat race circuit or rat race coupler. For an ideal hybrid ring coupler, that is rat race circuit, as it is ideal, it must be a lossless one with perfect isolation between input port and decoupled port. These are implications of idealness in the rat race circuit. Its scattering matrix appears as S is equal to 1 by root 2, 0 minus 1, 0 minus 1, 1 0, minus 1 0, 0 1, 0 1, minus 1 0, 1 0. This matrix is with respect to the port numbering that is given in the symbol shown by the side of the matrix. 1, 2, 3, 4 clockwise numbering is given. A point requires to be mentioned here. S matrix is specific to port numbering. It implies matrix depends upon port numbering. Matrix changes when port numbering is changed, varied. Now we consider the actual process. of modeling rat race with S parameter. As is the case with any circuit or device, the starting point in the procedure is finding the order of the matrix. Order of the matrix depends upon number of ports in the device. As the device is a 4-port one, its S matrix must be a 4 by 4 square one. Let it be S11, S12, S13, S14, etc., etc., etc. Ultimately, last element is S44. Now, somehow we have to fix values to this parameter. 16 in number. The diagonal elements are zeros because all ports are perfectly matched to the junction. That is, port 1 is matched to the junction, port 2 is matched to the junction. Similarly, 3 and 4 also. Hence, S11 is equal to S22 equal to S33 equal to S44 equal to 0. Some other elements are also zeros. S13 and S31, they are also zeros because of a perfect isolation between 1 and 3 ports. S24 and S42, these two are also zeros due to isolation between 2 and 4 ports. Incorporating all these aspects, the S matrix for hybrid ring appears as 0, S12, 0, S14, S21, 0, S23, 0, 0, S32, 0, S34, S41, 0, S43, 0. Notice the reduction in the number of unknowns. To begin with, it is 16. Now it is not so. Number of unknowns are fewer than 16. The input at port 1 appears equally divided at ports 2 and 3, but with the phase opposition. Thus, S21 becomes equal to 1 by root 2 and S41 becomes equal to minus 1 by root 2. When the input is at port 2 on similar grounds, S32 is equal to 1 by root 2 and S12 is equal to minus 1 by root 2 by considering input at port 3. S43 equal to 1 by root 2 and S23 equal to minus 1 by root 2. Also, by considering input at port 4, S34 becomes equal to 1 by root 2 and S14 becomes equal to minus 1 by root 2. Now, these values can be inserted into the matrix. After insertion, number of unknowns are no more present in the matrix. Now the matrix is 1 by root 2, 0 minus 1, 0 minus 1, 1, 0 minus 1, 0, 0, 1, 0, 1, minus 1, 0, 1, 0. Note, the sign of the matrix elements depends upon the assumed polarity of the waves. It is valid even when the signs or the elements of each column are interchanged. Here one point is required to be mentioned. Modeling of circuits with S parameters. It is not mechanical. Not only in modeling, not only with S parameter modeling, in engineering, involvement of the being in doing things gives the best and correct results. One can notice while doing modeling, what we are doing exactly is we are converting the properties of the device into an S matrix. We are inserting the nature of the device into S parameters. This insertion process, this conversion process, it requires certain amount of knowledge in using S parameter to model the circuits. These are the things which I want to share with you for right now. To recap, here in the session, we considered two 4-port devices. They are Magic T and rat race circuit. Their S matrices are derived. While deriving the S matrices, the procedure that is followed commonly, the steps that are involved in that procedure, all these aspects are explained, shown, illustrated with an intention to give a clear idea and understanding regarding modeling with S parameters. Hope you have a wonderful and beautiful, successful and fruitful and excellent and enriching learning experience. Enough for now. See you again soon. Bye.